Let's do some more problems involving Newton's laws. Okay, so this problem that I'm taking from, I think it's from Oregon University. It's zebu.uoregon.edu. I want to give them credit for their problems, but let's see. Let me draw. It's going to be the ground. Okay. And then the problem says that I have a train on the, so this is a train. Try my best to draw a train. I don't know, something like that. Right, and there's smoke coming out. And it says the train of mass 6.84. So let's say the mass of the train. The mass of the train is 6.84 times 10 to the 6th kilograms. That's the mass of this train. Is moving at a speed of 80 kilometers per hour. So its velocity, we could say its initial velocity because I think it's going to ask me what happens to its velocity. So its initial velocity is equal to 80 kilometers per hour. And see the brakes, so it's going this way at 80 kilometers per hour. 80 kilometers per hour. The brakes, which produce a net backward force of, so the brakes are gonna pull backwards, right? They're gonna a net backward force of 1 point. So force is equal to 1.93 times 10 to the 6th newtons. That's 1.93 times 10 to the 6 newtons. I know it looks a little bit messy. That the brakes are going to be applied for 25 seconds. So the force of the, I'll say force sub B, or the force of the brakes, is 1.93 times 10 to the 6th newtons, and then they will be applied for 25 seconds. So the first question they ask is, what is the new speed of the train? So what is the speed of the train after the brakes are applied for 25 seconds? Well, all we have to figure out is how fast is the train decelerating? Or what rate of deceleration does this backward force create? So we just go back to our basics. Let me switch colors because this red's getting a little monotonous. Force is equal to mass times acceleration. Probably the easiest formula ever to memorize. And what's the backward force? The backward force is 1.93 times 10 to the 6th. So 1.93 times 10 to the 6th. And that equals mass times acceleration. What's the mass? Mass is right here. 6 point, that's a decimal there. 6.84 times 10 to the 6th times acceleration, right? And acceleration is what we're trying to figure out. And remember, if the force is pulling back, then of course the acceleration is also going to be backwards, or it's going to essentially slow down the train. So I know this is very messy, but let's just divide. Well, we could divide both sides by 10 to the 6 just to get that out of the way, and that simplifies things a little bit. And then we're left with the acceleration. I'm just flipping both sides of this equation. Acceleration is equal to 1.93 divided by 6.84, and this is going to be given in meters per second squared, right? And I just want to make sure I got all my units right, because this number here, the mass was in kilograms. Right? And then the force was given in newtons. So the acceleration will be in meters per second squared. And let's get the handy calculator here, because this looks, I don't want to waste your time reviewing how to divide decimals, although that might not be a bad review, most people forget. 1.93 divided by 6 point, whoops, I think I messed up. So let me see. 1.93 divided by 6.84 is 0.282. So acceleration, it's acceleration is equal to 0.28. Let's just say 282 meters per second squared. And so how fast is the train going to be going after 25 seconds? So what's the change in velocity? Well, the change in velocity is equal to acceleration times time. And if we take its velocity as a positive number, then its acceleration will be a negative number, right? Because it's going to be going in the opposite direction. Could have done the other way around. So the change in velocity is going to be equal to this minus 0.282 meters per second squared. I won't write the units here because I'm running out of space. Minus 0.282 meters per second squared times 25 seconds. And let's get the calculator back here. Where'd it go? There it is. Okay. So now we want to multiply that number we just figured out times 25 times 25 equals 7.05. 7.05. So the change in velocity is equal to minus 7.05 meters per second. Okay, so let's see what's going on. The initial speed of the train is 80 kilometers per hour. But we have the change in velocity given in meters per second. So we could either change this change in velocity into kilometers per hour, or we could go the other way around and do the or change the kilometers per hour into meters per second. I don't know. Let's change the meters per second into kilometers per hour. So there are how many meters? So it'll be minus 7.05. And how many meters are there in a kilometer? Well, there are 1,000 meters in a kilometer. So it's going to be going that number divided by 1,000 kilometers. And if this is a little confusing, I'm skipping a couple of steps. You might want to review the video on unit conversion. And then this is meters per second, but we want to get kilometers per hour. So it'll go, how many seconds are there in an hour? There's 3,600, right? So it'll go 3,600 times as far in an hour as it does in a second. So times 3,600. And so we can get rid of 2 zeros here and 2 zeros here. So it's essentially going to be 7.05 times 36. I just got rid of zeros. I'll write the zeros there just so you don't get confused. Divided by 1,000. 1, 1, 2, 3 equals 25.39 kilometers per hour. So I'll just round 25 kilometers per hour. So the change in velocity is minus 25 kilometers per hour. So that's how much. What's the change in velocity? If it was starting off at 80 kilometers and then the change in velocity is minus 25, what's its new velocity? Well, it's going to be 80 minus 25, the initial velocity minus the change in velocity, or plus the change in velocity, depending on how you view that negative number. So 80 minus 25, so we could say the final velocity. The final velocity is going to be 80 minus 25 is 55 kilometers per hour. Now the second part of this question is, how far has the train traveled in this time? So essentially, how far does the train go as it breaks from 80 kilometers per hour to 55 kilometers per hour? Well, all we have to figure out is the average velocity and then multiply that times the time, right? So what's the average velocity here? Let me just clear this because I think it's getting to, you don't need a drawing of a train. See if I remember so the initial velocity was 80 kilometers per hour. Final velocity is 55 kilometers per hour. So the average velocity is going to be 80 plus 55 over 2, which is what? 67.5? Something like that. Right, 67.5. 67.5 kilometers per hour. And then if we want to figure out the total distance it travels, distance is equal to average velocity times time. The average velocity, well, we have the time in seconds, right? So we have 25 seconds here. But this is given in kilometers per hour. So we want to convert this into maybe meters per second. So what we do is take the 67.5. It's going to go times 1,000. That's how many meters it's going to go. And then in a second, it's going to go 1/3600th of that. So let's see what that gives us. 67.5 times 1,000 divided by 3,600. 18.75. 18.75. That's the meters per second. That's the average velocity in meters per second. And we go for 25 seconds. So what does that give us? Times 25 equals 468 meters. 468.75 meters. That's how far it traveled just to break from 80 kilometers per hour to 55 kilometers per hour. And it took 25 seconds. Hopefully I haven't confused you too much. See you soon.